Building a GPT model with browsing capabilities using LangChain tools. A tutorial on integrating Google SERP, DuckDuckGo, Wikipedia, and YouTube into GPT models using Python and LangChain tools. One of the new features I really appreciate in ChatGPT is its ability to browse the internet to fulfill users' requests when further information is needed. Nevertheless, I've encountered two issues so far. Browsing capabilities are only available to ChatGPT Plus users. Users can access the browsing capabilities through the user interface, but not when interacting with the model via the API. It turns out that LangChain has addressed these issues by releasing the so-called LangChain tools. In this tutorial, we will learn how to use LangChain tools to build our own GPT model with browsing capabilities. Here, browsing capabilities refers to allowing the model to consult external sources to extend its knowledge base and fulfill user requests more effectively than relying solely on the model's pre-existing knowledge. Scope and objectives. This article covers the basics of LangChain tools and how to use them in Python. We will be using a Jupyter notebook with both the OpenAI and LangChain libraries installed. In this tutorial, we will learn how to utilize 4 of the existing LangChain tools to provide the default GPT model with a variety of external sources to consult while fulfilling user requests. Specifically, we will explore tools that use the following sources. 2 well-known search engines, Google SERP and DuckDuckGo Search. Wikipedia as a comprehensive and widely recognized information database. YouTube sources for obtaining video suggestions from the model. After setting up these tools, we will have learned how to generally use any LangChain tool and how to combine them all in a toolkit to provide the model with browsing capabilities. Introduction to LangChain tools. As we discussed in the introduction, LangChain tools can enhance a model's capabilities by enabling it to consult external sources when responding to a user's prompt. These tools are instrumental in a prompting technique known as ReACT prompting. ReACT, an acronym for reasoning and acting, divides the model's processing into 2 stages. Reasoning stage. In this phase, the model takes time to consider the best strategy for arriving at a response. Acting stage. Here, the model executes the plan formulated in the previous stage to obtain the actual response. This process generates reasoning traces that can guide the model itself towards the correct response. This technique has been shown to help large language models, LLMs, achieve more accurate and reliable responses, particularly in knowledge-intensive and decision-making tasks. This is partly because it allows the model additional time to think. LangChain tools can further enhance the ReACT prompting technique by providing complementary information sources. In our approach, the reasoning stage involves the model deciding which tool to use based on the user's query. Meanwhile, the action stage will enable interface with the chosen external source to gather additional information. LangChain elements for ReACT prompting. There are 2 important elements within the LangChain framework to make use of this prompting technique: agents and tools. The so-called agents are entities responsible for executing the actual reasoning and acting stages. They pass the results back to the model, enabling the LLM to generate a response with the additional information in natural language. There are various types of agents, each suited to different tasks you might want the LLM to perform. A detailed overview of the different types of agents is available in the official LangChain documentation on agents. Tools have been a significant focus of our discussion already. Technically, tools are functions that an agent can call upon. LangChain offers a wide array of tools, such as Google utilities, such as Search, Drive, and Scholar, Wikipedia searches, the RxIV database, a shell extension, and native ChatGPT plugins, among others. In this article, we will get to know 4 of them. Setting up the OpenAI environment. As with any other project that utilizes GPT models, the first step would be to load the OpenAI API key into our environment. To do this, we will use the OS and OpenAI modules. Because we will be using the LangChain framework, we will also load the actual GPT model from the LangChain library. In this case, we're using the GPT 3.5 Turbo model as the no-cost option, but feel free to use any other model of your preference. In the following section, we will learn how to set up our first tool. We will use the DuckDuckGo search tool as an example, but you'll see that all the tools follow the same steps to get up and running. Setting up our first LangChain tool, DuckDuckGo. DuckDuckGo is a search engine that emphasizes protecting users' privacy. Unlike some other search engines, DuckDuckGo doesn't track its users' search history, which means it doesn't create or maintain a personal profile of its users. It has a Python library that we need to install to use the search engine. It is installable via pip. In addition, we need to import the DuckDuckGo tool from the LangChain library. The method DuckDuckGo search run by itself already allows browsing the internet without interfacing with any LLM. Let's see a simple example. Screenshot from the ddg search.run execution for browsing the internet with DuckDuckGo. The idea behind tools is to integrate this browsing capability into an LLM so that we can get a coherent response in natural language instead of retrieving just the raw piece of information. To do so, we need to embed this method into an instance of the LangChain tool class as follows. Any tool needs a name that the LangChain agent will use to refer to it, a function func that the agent can execute to consult the external sources, ddg search.run as shown above, and a description that can be used to provide information to the agent about when to use it. For this example, we have selected the following description: useful to browse information from the internet. Exploring other browsing tools. Once we have learned how to set up our first tool, setting up the rest should be quite straightforward since they all follow the same structure. Google Serper tool. Google Serper is a low-cost Google search API that allows us to browse the internet as DuckDuckGo. For this tool, we need an API key that we can get by signing up for a free account in /serper.dev/. Once we are in our Serper account, we should be able to see the API key option in the left side panel. By clicking on it, we will get the API key that we can easily copy and integrate in our Python scripts. Going back to the code, we can easily import the key to our environment. To use the Google Serper API, we need to first install the required Python library, pip install Google Serp-API. In addition, we need to import the Google Serper tool from the LangChain library. As in the previous case, Google search.run is also a method that will independently browse the internet. Nevertheless, again, the idea is to integrate it as a LangChain tool as follows. Wikipedia tool. Let's complement our set of tools with the well-known Wikipedia sources following the same process as with the previous tools. The first step is to install the Wikipedia Python library via pip install Wikipedia, and load the required modules from the LangChain library. This tool actually needs 2 modules due to the Wikipedia API architecture. Finally, we can append a new instance of the tool class with a function running the wikipedia.run method, YouTube tool. Finally, I found it very interesting to integrate the YouTube sources so that the model has an additional capability to answer back in the form of videos, not only written text, following the same procedure as before. Now we are ready to go. We have built a toolkit, tools list, with the 4 tools providing browsing capabilities to our model. Nevertheless, we haven't interacted with the model so far. Conclusion. In this tutorial, we have learned about the use of LangChain tools to enhance browsing capabilities in LLMs. Central to LangChain is its ability to streamline the development of LLM-based applications, showcasing a suite of powerful features including built-in memories, complete chatbots, and the tools explored in this article, among others. While OpenAI is making strides in the realm of customized AI with the launch of its latest GPT models, I believe there is still significant room for growth and innovation. In this regard, LangChain tools hold a substantial advantage in this technological race for users who frequently interact with GPT models through Python and the OpenAI API. This stands in stark contrast to GPTs, which appear to be tailored for a non-coding audience. GPT users can easily configure a specialized instance from the ChatGPT user interface and access it as needed, offering user-friendliness but limited flexibility.